Now let's move on to the next technique of data encoding, which is hash encoder. So what is hash encoder? So to understand hash encoding, it is necessary to know about hashing. So hashing is the transformation of arbitrary size input in the form of a fixed size value. So let me write down that. So this is hash encoder. So out of that, first let's look into the hashing. Yeah, hashing is a process of converting any input data. That could be any input data, example text, numbers, any other type of data. Okay, so any other type of data. So hashing is a process of converting any input data into a fixed size string of characters, which is typically a sequence of numbers and or letters, which is typically a sequence of numbers and letters. Okay, so now the output is known as the hash code or hash value, is a unique representation of the input data. We use this hash value even in Git also. Okay, Git. So hashing is commonly used in computer science and cryptography applications. Computer science, Git. So there's a Git commits numbers or IDs or hash IDs. Then we use and also for the cryptography. So and also cryptography and for tasks such as data storage, data retrieval, data integrity verification, and password hashing. These are the tasks that we will do with this hashing. Suppose we have a text string saying Hare Krishna. Let me check the input here. Example. So text string, that's Hare Krishna. Yep. So we have an text string Hare Krishna, and we want to hash this text using a hash function. The hash function takes the input Hare Krishna and applies a series of mathematical operations to convert it into a fixed size hash code. So which would be something, let me convert that. Hash code is equal to hash, yes, you see that, hash, and then text, and hash code, here is that. Then your hash code would look like this. The resulting code is unique to the input Hare Krishna. Even a slight change in the input such as Hare Krishna with the exclamation mark will change. Even a slight change in the input such as Hare Krishna with exclamation mark will change it to the unique one. The resulting hash code would be a unique one. Okay, let me change this see, this is what the code we got now. So now let me change it. I'll just change this, and let me put it as text1, and take this value here, bring it here and put text1, and then this is hash code 1 and print hash code 1. And you see that the difference, the smallest change, slightest change, but the hash code as changes a lot. So the hash function used in this example is just simple illustration, and real world hash functions are much more complex and secure, designed to produce unique hash codes with low collision probability. So hashing is widely used in various applications such as data storage, data retrieval, data retrieval, data integrity, data integrity verification, and password hashing, and digital signature. Very important, very important, digital signatures, and many more. Okay, so now let's get back to our hash encoding, because we have seen what is hash encoding. Now let's look into our hash encoding now. So hash encoding, as we have discussed earlier, is a type of categorical encoding technique that assigns a unique numeric value. It's nothing but a hash code to each category in a categorical variable based on a hash function. It's a non-linear encoding method that can be used to convert a categorical variables into numerical representations for machine learning algorithms. The hash encoding process involves applying a hash function to each category in the categorical variable, which produces a fixed size output regardless of the length or complexity of the input. The hash codes are then used as a numerical representations of the categories in the encoded data set. Now let's understand the hash encoder with the illustration. So we have taken the similar data set where the gender has three categories: male, female, non-binary category. Now I just want to convert this into the hash encoder. How does it possible? This is the way. Hash encoding, will be using the hash encoding method or any other way. So then after applying the hash encoding, and this is how it will be converted. So the male will take some hash encoded value, and similarly non-binary will take hash encoded value of 4, and female will take hash encoded value of 5, and whenever the male comes it will take 9, whenever the female comes this will take 5. And this is how the each category of the gender will be hash coded using the hash encoder method. Now it's time to jump into the Jupyter notebook and do an example. So let me import hash lib also. So hash lib has been imported. Now let's take the same data whatever we have used on top. So the data name is df. Let me call upon. Yes, no gender, I don't want this. Okay, let me take this one. Let me directly copy the code and put it here, and df. Yeah, this is what I want. This is my data frame. So now I need to perform hash encoding. I need to perform hash encoding. So what's the hash size you want to go with? I'm going to go with the hash size of 10. So specify the size of the hash code here, and then let me add this as gender hash encoded. Okay, and df of gender, and then we need to apply a specific function. That's it. That specific function also would be from using lambda, because that's what will give you anonymous function. Let me go for the apply apply method, and now I have to attach an anonymous function saying lambda, and then parameter is x, and int of our operation hash lib dot md5 and x dot. So x dot, go for the encode, and encode, I'm going to go with the UTF-8, and so apply the hex digest, and I'll go for the 16 hex digest 16, and finally hash size. Just look at this code one more time. Gender hash encoded, then gender column, and we have created a lambda anonymous function which is applied to the gender column. Okay, so now let's print this and see. So display the resulting data frame. So print df, and that's it. That's your hash encoded gender column. Gender hash encoded 95495. That's how we do the hash encoding.